This video is about subroutines in assembly programming language. So some key concepts that you have to be familiar with before we get started are basic assembly programming knowledge, loops, pointers, counters, and the difference between direct and indirect addressing. So you might be wondering what a subroutine is. So basically it's a piece of code that can be called from the main program. You would use a subroutine when you have code that has to be repeated a lot of times in your program. So you just take the repeated code and you would put it in a subroutine and call the subroutine every time you want to use that specific code. If you're familiar with Java, we call this a method, or in Python, we call it a function. But since we're not coding in Java or Python, we're coding in assembly, the way we write a subroutine is going to be a little bit different. So just like in regular assembly programming, to write a subroutine, we're going to be using the list of predefined instructions that we have available. It depends on what your teacher or your professor gave you, but for the case of this video, I'm going to be using the instruction list of Nano's Basic Computer. I'll put a link to this table in the description and you should be referencing it while you're writing your subroutine. Although all of the instructions are important, the two most important are probably going to be bun and ISC. Bun is branch unconditionally to a specific memory address, and ISZ is going to be incrementing M and skipping it if it's 0. So you'll see these two instructions in every single one of our subroutines, so it's really important that you know how they work. Some variables that you'll also see in most of our subroutines is pointer, which is a variable that will hold an address location, and we can increment it using the ISZ command. And then we can also use ISZ to increment our counter, which is a variable that's going to count how many times the loop is going to be executed. To initialize the counter, we would make it equal to the negative amount of times that the loop will execute, so that when the loop has executed the amount of times we want it to, the counter should be equal to 0, and we can use the ISZ command to check to see if it's equal to 0. Now let's go over initializing counters just in case there's any confusion. So to initialize a counter, let's say we have a loop and we want it to execute num amount of times. So the amount of times you want the loop to execute is going to be held in the variable num. First thing we need to do is we need to load num into the AC. We're going to complement it. We're going to increment it by 1. And we're going to store the result into our variable called counter. And then we'll clear the AC. So what this code does is loads num into AC and it stores negative num into the variable counter and then clears the AC when we're done. The best way to understand a subroutine is to actually go ahead and start writing them. So let's start off with an easy one, then we'll go on to something a bit harder. So the first subroutine we're going to do is going to multiply two numbers held in the locations num and mul together. If you go back to the instruction list I showed earlier, you're going to notice that there's not actually an instruction that we can use to multiply two numbers together in the AC. So we have to find a way to write this in assembly. So let's take the example of 2 times 3. So if these are the numbers we're going to multiply together, we can just remember that multiplication is repeated addition, and we can see pretty quickly that we'll be able to use a loop to solve this problem. So for this, we would just add 2 together 3 times. So our num is going to be 2, and then our multiplier is going to be 3. So what this means in terms of our subroutine is that the loop would add num to the AC mul amount of times, and our counter should be initialized to negative num. So now that we know exactly what we're doing, let's write the subroutine. Alright, let's go ahead and start writing our subroutine. It's not going to be any different than just writing a program in assembly. So the first thing we're going to do is initialize our counter. And as we mentioned earlier, we want our loop to run mul amount of times. So let's go ahead and load mul into the AC. Let's complement it. Let's increment it by 1. And let's store the results into counter. And let's clear the AC. Now let's start writing the actual loop. So I'm going to call my loop lop, and the first thing I'm going to do in my loop is add num to AC. Next, I'm going to increment the counter. If the counter is not equal to 0, we're going to start the loop again. So I'm going to bun to lop, and then if it is 0, we're going to halt our subroutine. So That's basically the code that we need to write the basic subroutine to multiply the numbers, but there is one thing we're missing, and that is all of our variables. So let's go ahead and add our variables at the very end. So in the variable mul, we have decimal number 3. In variable num, we have decimal number 2. And in the variable ctr, we start off with 0, but we do change the value later. And now that everything's done, let's go ahead and end the program. So this is our total program. And this is not all. There is a bit of an extra challenge. If you can add code at the beginning of the subroutine to check to see if the multiplier is equal to 0. So if you want to add that little condition at the beginning, I'll put the code for that in the description. So go ahead and try it by yourself and check your answers after you're done. Alright, this next example is more difficult than the one that we just did, but even if you don't know it, you already have all the knowledge you need in order to write this subroutine. So let's write a subroutine that adds 100 numbers together that are stored in consecutive memory locations starting from location 200. And just to make this difficult, we'll just do this all in decimal. So let's go ahead and declare all our variables first, just so that we know exactly what we're doing and we don't get confused when we're actually writing in assembly. So the first variable I'm going to have is going to be num, which will store a decimal number -100. And then I'm going to have variable ads, which is going to store the starting address of the first number we want to add. I'm going to have variable pointer, and let's just initialize that to 0 to start off with. I'm going to have variable counter, and we're going to initialize that to 0 as well. And then let's have a variable called res for result, and we'll initialize it to 0 as well, and then we'll store the result of all the additions at the very end into res. So now that we have all our variables declared, we can just use that for reference. And let's go ahead and start writing our actual subroutine. So the first thing we're going to want to do is initialize our pointer and our counter. So let's start off by loading num into AC. The next thing we're going to do is we're going to store that into our variable counter. So counter is now going to be equal to -100. Let's clear the AC. And now let's do the same thing with pointer and address. So let's load in ads into AC. Let's store what's in AC into pointer. Let's clear the AC. Now we're ready to actually start writing our loop. So like in the last program, I'm going to call our loop lop. And the first thing we're going to do is we're going to add the pointer indirect into the AC. So the reason that we're going to add it indirect is because the pointer, so to start off with, for example, for the first one, pointer is going to have the value of decimal 200. And then we want to add what's stored in address 200 into the AC, so that's why we're going to be using indirect. And then next, let's go ahead and increment our counter and our pointer. So we're going to use ISC for both of that, so increment pointer. And let's increment counter. So if our counter is not equal to 0, we're going to branch unconditionally back to the start of our loop. And if the counter is equal to 0, let's go ahead and store what's in the AC into result. And then let's halt our program. So there we go. That is going to be how we're going to do this program. And then now that we have all of our variables, let's just go ahead and add it to the end of our program. And then let's put end at the end to signify that that's all of our code. So there we go. That's our complete subroutine. Thank you for watching the video. I did reference the textbook Computer System Architecture, the 3rd edition by Morris Mano, and it is a very good book. If you have an exam or a midterm coming up, I wish you luck, and I'll see you in my next video.